You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
You know how people tell you, if you get nervous when on stage, picture people in the audience naked. Like it's this thing that's supposed to make you feel better. But I was thinking, picturing all of you naked in 2018 feels kind of weird and wrong. Like we're working really hard on moving past stuff like that. So we need a new method of dealing with if you get nervous on stage. And I realized that what I'd really like is that I can look at you as much as you're looking at me, just to like even things out a little bit. So if I had way more eyeballs, then we'd all be really comfortable, right? So in preparation for this talk, I made myself a shirt. It's googly eyes. It took me 14 hours and 227 googly eyes to make this shirt. And being able to look at you as much as you're looking at me is actually only half of the reason I made this. The other half is being able to do this. So I do a lot of things like this. I see a problem and I invent some sort of solution to it. For example, brushing your teeth. Like it's this thing we all have to do. It's kind of boring and nobody really likes it. If there were any 7-year-olds in the audience, they'd be like, yes! So what about if you had a machine that could do it for you? I call it the toothbrush helmet.
Morning, everybody. Hi, this is Mike Balzer, and this is All Things 3D, 3D in Review for, what is it, 11th May 2018. It's been a while. So the person you just saw was Simone Giertz, and she just, I guess it was just published, so I don't know when the actual event occurred, but she did a TED Talk, and essentially about how to create useless things. And the reason that I'm familiar with her is because I was looking for techniques in creating, as I mentioned, my Bluetooth shock collar. And I came across one of her videos and I found that she was extremely amusing, very energetic, and obviously very enthusiastic with the stuff that she's doing. And more importantly, she was very, what do you want to call it, close to the audience. However, I have followed her on a few other videos, and then just recently I went out and she had done a very heartfelt, sad video about how she had a brain tumor behind her right eye. And if you've looked closely at her, you'll notice that she already has some deformation because of it. And clearly the thing that I had thought of, and some of you who have been following the show for some time now, my wife also had a tumor, except it was on top of her left eye. And luckily it was what they call a bony meningioma. So it actually was growing up into her brain cavity, whereas I'm assuming Simone's more than likely has a meningioma as well. And it was growing. I don't know if it was a bony meningioma or just a regular one. I don't know that much information about it. However, she has actually gone out and had a diagnosis, and I guess next week, she's actually getting surgery here in the United States. Now, I reached out to her to let her know that that I had done a TEDx talk and talked about our experience in discovering, as well as my 3D fabrication of my wife's skull, and then actually going to the University of Pittsburgh Medical Center to have an excellent neurosurgeon, Dr. Gardner, and an can't even talk, the ophthalmologist, Dr. Gosh, now I've already forgotten her name. Well, it's in my notes, though. But both of them worked as a team because of their expertise, one in ophthalmology and the other one in neurosurgery in order to remove it. And it was a very tedious and lengthy process. And the thing that I mentioned at the end of my TEDx talk was the comments that he made was he put the extra effort in so that the patient doesn't have to suffer. So one of the things that if this tumor is where I think it is, they will probably take out part of the brow in order to remove it. Hopefully that's where it's located. In my wife's case, since it was underneath the brain, they would have had to do a standard craniometry and use traction on the brain and lift the brain out in order to remove the tumor, which has all kinds of side effects and consequences. So the term or the method used with her was literally drill into above her eye. So that means they had to move the eye itself and remove some of the bone there. Actually, it was a fairly large size in order to remove the tumor. And so far, everything has been working fine. Her latest CT scans have been working well. So again, I hope the best for Simone, because we want her to get back on YouTube and to come up with some more wacky ideas. And hopefully she will take her and hope things go well for her. Worst case, she might lose the sight or actual eye. I hope that won't be the case, but hopefully there's a positive output and she puts her experiences into what she can possibly do in order to invent new useless things for hospitals and so forth. So we'll see where that goes. But that's not the purpose of the show today. The purpose of the show today is to talk about the main theme, which is our VR AR companies, or actually system manufacturers failing developers. And the reason that I'm bringing that up is that we had Google I/O, which happened on Tuesday, and two products were just announced recently prior to Google I/O 2018. And one of them, which I'm going to talk a lot more about later on in the show, is Google Seurat. And some of you may be already familiar with it. I think it's a very cool application because it allows the developers to use some unique techniques, but we're going to look at behind the mirrors because it's kind of a magician's trick and realize that it may not be all what it's what do you want to call it, cracked up to be, and it may not actually solve all the problems, but it's unique, and so we'll go through a lengthy discussion on that. But the other thing was VR 180, and I've talked about that, shown it at on the show before. And again, that meaning the developer portion of that was just released 2 or 3 weeks ago. So both of these they were announced practically over a year ago at Google I/O 2017, and just now making the light of day. In fact, they just announced, I don't even know if you can get it yet, the Lenovo Mirage, I think, is the camera system, which is VR, and then obviously there's a couple of other manufacturers. But I think all of them are sitting on the fence. But more importantly, the developers themselves have had no tools to work with in order to create something with these applications. And I have some theories on that, but they're not the only ones that have acted that way. As you know, I have mentioned on the show before, I have reached out to HTC Vive, and basically it's been crickets. And even though they've reached out to me for some assistance on something that I was working on with the Unreal Beta mixed reality video system, and I was hoping that there might be some reciprocity in this and allow me to maybe get an early preview of the the HTC Vive Pro. And even then, they didn't provide me any information on it, as well as not even an opportunity to buy it early. So I've kind of been frowned or a little disappointed with maybe a lot. And there's other examples too. For instance, Google's Daydream. As you know, I've developed a headset that I think is unique that allows basically to put your phone in a very open frame, so that some of the issues with Daydream and Gear VR is they because of you're basically running the processor and the GPU at full throttle, there are heat issues. And my design basically dissipates all the heat because there's nothing containing it. And both the Daydream headset as well as the Gear VR have issues in that area because there's obviously very little ventilation. The other thing is that my optics are standard Pima grade glass. They're not Fresnel lenses, so I think they're sharper. So I had a unique design. However, Google, in their infinite wisdom, unlike cardboard, has made their system kind of closed. And since this basically is a headset that requires new configuration for the optics, they have not really allowed anybody other than their own Daydream headset to utilize what do you want to call it? They weren't using a QR code, they were using an NFC tag. Any other options besides their two Daydream headsets? Now, even though the 2017 Daydream headset is better, again, I still prefer mine. It's a sharper screen and it's a more open design. And I have not had any issues with my system having to throttle back. But the other thing is their little control. There have been a couple of Chinese OEMs who've created very low cost versions. In fact, one of them I think is a little more ergonomic. And again, you can't, even though you can substitute if you have a Daydream headset, you can't go out and buy one of those and use your clone or OEM headset, cardboard headset, even though it should function, because one, it doesn't list it as a device, even though it pretends to work with it. But more importantly, they have now hampered the navigation system while wearing the headset. In fact, you can't get a listing of your own apps that you have downloaded previously. There's a library selection in Daydream. That no longer functions if you're not using the default Daydream headset, either the original or the 2017. So you have to actually select your app before you put on your headset, which gets you back to the cardboard days and negates all the functionality and flexibility with the Daydream ecosystem. So I have some issues with that as a hardware designer. And also from a software perspective, especially with this Seurat, which is supposed to be this new tool to allow Daydream developers, especially with their new 6 degrees of freedom system, I believe it's Lenovo Mirage again, that has the ability to be able to move your head around, but I'll get into a moment why even that isn't as dramatic as you would think it would be. But even Seurat has taken a long time to come, and I think they played some favorites with other companies. For instance, I guess there's an app coming out, if it's not available already, Blade Runner Revelations has had access to it. Then obviously the ILM-XM lab has had access to it since they put out 2 different videos. But standard little developers like myself have waited years. In fact, the tools just came out, and sadly, they don't work. Parts of them work, but if they are basically so raw, for instance, there is no binaries, meaning you just can't run an executable to, use any of these features. They're all made specifically for developers. So that's kind of disappointing in itself. That you have to wait so long, and then finally when it comes out. So other companies that I've had issues with, obviously Apple's a fine example. Even though they've been very good in working with developers, getting the developer Xcode out, beta stuff, as well as beta software kits. As far as hardware, you pretty much have to wait unless you're special with everybody else. In fact, even as a hardware designer designing cases and so forth, unless you're a big OEM, having access to this or signing an agreement, which I think costs a little bit more money than just the standard $99 developer fee, you have to sign an agreement, and then obviously you may have access to, I don't know if there'll be actual CAD files, but the mechanicals, which is the layout, specific measurements of the different phone devices. So all of this is not available to your little developer until later on. And let's even look at Oculus. Oculus, if you remember back when they first started, really relied on the Kickstarter and people being involved. They made a developer system readily available in the beginning, made the kits, the developer kits, readily available. And this kind of helped build the ecosystem. And then they decided to close the doors on it. Now it's very difficult for people to find out what's going on behind the doors and what's coming up with them. And it seems like many companies are now taking this direction. And as you know, I've worked with Occipital for many years, and I found that they also have been doing something similar to that. But I've also know, as having close ties with them, I may have access and had certain things done that other developers may not have. So there's a lot of favoritism going on. And I think we need to get back to a more open environment so that we can create some protocols and platforms that people can access to. And then probably the worst one, and as you know, I complain a lot about them, is Magically super secret. And even though I've signed up as a developer and I have access to some of the software, I don't actually have a Magic Leap kit, nor have I been invited yet to buy one. So any kits that have been available are only available to those who obviously might be a bigger name, have more potential, but Magic Leap is making all the decisions on who gets these and what kind of software will be available. A little bit like when Oculus in the beginning, in what they're releasing. And the sad fact is, what the consumers may want and what the manufacturers or developers, not developers, or system manufacturers may want are two different things. And not having a system available on the onset doesn't allow enough to flourish that the consumers can say, I like this or I don't like that. And it's really disappointing because I think they need to put more effort in keeping the system, or at least from the developer's perspective, more open, communicating more. And frankly, the only people that I think have been doing a much better job with that is Microsoft. I know that seems very strange, but Microsoft always seems to send me emails asking me if I need any more help, where do I need to go in developing my apps? And clearly there's some reasons for that. They want their Microsoft, as I call it, XR, their mixed reality headset, which are nothing more than VR headsets with 6 degrees of freedom built into them. They want to have more software built specifically for it, but now that they have Steam VR, they want to have the ability of having the Steam VR system more prominent, meaning they listing the headsets. And that's happening more and more, which allows more freedom from the developer of just creating a open VR, what do you want to call it, app that can work on the Oculus, Steam, or the HTC Vive and mixed reality headset. And I've done that a couple times and it seems to work really well. So even that they're trying to push, and the tools have gotten a lot better because they're wanting to have more penetration. And the fact is that you can pick up a headset between $200 to $300 to work with not necessarily a low-end PC, but a medium, gives you an opportunity to work directly into it. And some of the apps actually are fairly nice and are low cost. HTC Vive has their own store, but it's a little flaky. And then obviously we have Steam VR, which all works pretty well. But again, working directly with the hardware manufacturer is important. And right now, I think Microsoft, in some areas, now I've asked information about their hardware because I think there are things I can enhance with it that are not available yet. And so I'm reaching out. Some of the things they said won't be coming till later. So even they seem to limit a little bit what can be done and what can't be done. All right. So that's enough about the opening theme. So I do think that the system manufacturers need to work a little bit more with developers, make things more available to them, so that we can start working earlier on something that is coming out instead of waiting until they announce it basically to the consumer. By that time, there really isn't anything available, and that can create some problems in products. And one case in mind is the new Oculus Go. Even though I signed up earlier on it, I wasn't really that interested in the product. And I do think they've got a few of those out to your standard developers. So there might be more apps available for it. But right now, the only thing that you can have access to is Gear VR access, and there are some differences. Obviously, you can go with a higher refresh rate if you want to with the Go, and then the optics are a little bit, not optics, the LCD screens that are used in it have a higher resolution than what you have with your Gear VR. And most importantly, it's a self-contained system. So there are some advantages if you write directly to it. And now we're just slowly going to be seeing things that take advantage of it. Excuse me. So, I think I pretty much mentioned all of them. I haven't even ventured into the Sony PSVR system. I don't really work with that. And my experience in the past is that normally it's big developers that can afford the licensing fee. And so I'm not even going to talk about that. Okay, so on to our news items today. So let's look at one of the things that came up, and this is 3D updates from the past. As I would say, Kinect is back, baby. And yes, it appears Project Kinect for Azure, which is Microsoft's cloud system, is their new Kinect unit. And this is something, or I guess that's an image of it there, but let me change my screen. I apologize for not having that up. There we go. This is the new Project Kinect. Very compact. This seems to be the trend that a number of, I'm going to call it 3D sensor uh, companies are working with. This works very similar to their previous version 2 and version 3, which are time of flight systems. Now it looks like there are two image projection systems, and then obviously this is the camera here. In this article that was out on LinkedIn from the actual inventor, Alex Kipman, of the Kinect, and if you remember, was originally based on the PrimeSense. It has a higher number of pixels, a megapixel resolution of 1024 by 1024. In the past, it's been as low as 320, 640, and now we're up to 1024. Has a higher figure of modulation frequency and modulation contrast, which means more likely the lasers don't need to consume as much power. And that was one of the problems with the version 2 system that was made for the Xbox. And then you could buy a PC developer kit, which I had, that required a beefy little power box and I think consumed more than a watt of power. But here we're looking at 225 to 950, so that means you can make a more mobile system with it using a global shutter, which means the whole sensor is open at one time, so it performs its use in sunlight, and then a multi-phase depth calculation. So I'm thinking that's why we have two projectors, which adds more accuracy. So this is all, it's very vague. I guess there's a paper, but I couldn't actually find the paper. But as soon as this comes out, this is going to be very unique. I don't know the price of it. Probably will be fairly pricey up front. But having worked with the Kinect 2, the detail that you can get now, as far as a 3D capture system, it's not probably as good. But in fact, I have tried it, and you can go back to previous episodes where I've actually hooked it up to a laptop, and I felt the 3D scanning capability was a little underwhelming. But for our motion capture using the Breckle software system, it works very, very nicely, provides most of the bone structure. You can't really determine the bones in the hands, but I'm assuming with this little unit, you probably could. But the limbs all work very accurately. I think it works at 60 frames per second. So with this thing here, I'm assuming that we'll have even better results with it. It's kind of nice that they're still working with it. The other thing that they don't really talk about here, but the fact is that it's connected to the Azure system means that you'll be able to take advantage of machine learning in the cloud, which means you'll take the raw data, send it to the cloud, and then have it processed to be able utilize in the cloud. So for instance, if you're doing motion capture, you could send the raw depth and RGB information, and then it could interpolate that and provide you motion capture output, or provide you information about the 3D mesh information. There's a lot of things that could be done with it. and basically kind of in real time. I don't know if it'll be in real time. Clearly it has a dependence upon your connection to the cloud. But you'll be able to do some very interesting things to it. I signed up for it, so I'll report back later on. Those at Microsoft Build, which seemed to occur during the same time as Google I/O. So both of these were going on at about the same time. That was one of the things that was mentioned. Okay, so let's move on to the next item. I'm just throwing this in there because it's kind of fun. Engadget, designing a spaceship for the Guardians of Galaxy. I thought it would be more about 3D fabrication, but this has more to do with the computer-generated visual effects, namely the little video, which I'll show you here in a second. Here we go. If you remember Guardians of the Galaxy, it's kind of a fun little video that shows a lot of graphics. Engadget, so you can go out and read it yourself. There'll be a link in the show notes. So I thought that was pretty cool. And they don't really get into, and I was hoping, and maybe there'll be more information later on that we can talk to, since obviously this has been a huge hit. But it talks about some of the things that were created for it, some of the visual effects and so forth by different companies in order to provide a very unique alien, what do you want to call it, look to some of the things that are out there. Okay, so something else in the architectural design area. I thought this was pretty cool. This is by 3D Printing Industry. How about a tire? And I got a little video for this too, so let's go ahead and play it. So 3D Printing Industry did an article that basically using TPU, which can be extruded through standard printers. In fact, that's probably what they're printing in the background there. They were able to print these tires and then basically put them on a rim to provide a tubeless or airless system. And I don't know how well it works, but because of the lattice structure that's created, as you can see there, I don't have any, I guess we can go up to this. The lattice structure that's created here, it creates a very springy excuse me, surface that is applied to the frame and provides some damping. Again, I don't know how this compares to a regular tire, but if you need a tire, for instance, if you're doing off-road, I think they already have some, but they're expensive. But so this might actually solve that. And I guess they're also using something like this for creating an airless tire for cars as well. So it's pretty interesting. It's not the first time. Back in the old days, you used to have hard rubber tires, but now obviously using 3D printing and some of the new tools that create a more organic structure, open structure like this. You'll have a lot of the same flexibility and durability, actually more durability, and obviously the lack of actual punctures. So we'll see how this works out. I'll keep an eye on that. But I thought that was pretty cool. And the fact is, if you've got a large 3D printer, you'll be able to make one of these yourselves. But I think they're also selling it, so you could probably buy one. I don't know what um, tire frame or rims that it fits on, but they probably make it in multiple sizes. So yeah, it says made typically for a 26 by 1.5 inch tire. So very interesting. So if I ever get a bike again, I guess I'll get one of these tires. But somehow I have a feeling they'll probably be very expensive. Okay, 3Ders in org medicine. I thought this was pretty cool. Excuse me. Essentially, how about a handheld 3D skin printer? That's right. So imagine being able to, as they show in the illustration here, being able, oh, excuse me, sorry about that, be able to actually extrude this what do you want to call it, ink um, material directly on the surface of the skin, and then essentially makes contact, and I guess it's well, you can read the article, but it's something like a gelatin mass that's put on the wound. It blends with it and then allows skin to grow into it. And here are some examples of it being used. So I can see some huge potential there. And you could probably make a very small unit that could be set out for the military in order to seal skin wounds, burn wounds very rapidly, and allow them more than likely to prevent infection and other things from occurring. So I thought that was extremely neat. And clearly having something this small is going to be very useful. So you can read more about that on 3Ders.org. And again, the link will be in the show notes after the show. So very cool. And there's been several things, so I'll have a lot to talk about in the next few weeks. All right, on to the next item. And excuse me if my voice holds out. This is what I'm going to talk about the most today. And essentially, not that I haven't talked already a lot, Road to VR did a little article, and I've been following this some time. I've been very anxious for it because I have a couple of tools. So we're going to go through basically what's being presented in the blogs. This tool was just released, and it says May 7th, which I think was true. It's a few days before the Google I/O 2018. They've released it as they call open source. Somehow I think that means more like, we're not going to put any more effort into this, but here's what we've been working on. And somehow I don't even think that's the latest, but that's just my opinion. So how does this thing work? Well, this illustration does a good job. Essentially, this cube is important here. If you look down here, this is what they call the head box, and it literally provides snapshots with a camera of your mesh. Now, what they don't show is this head box moving. The camera actually moves randomly, I don't know, maybe a few inches left, right in different locations. And that's extremely important. And if you've done any photogrammetry, you'll find that this is very similar, especially if you've done photogrammetry that's only looking at part of an image. If you remember, photogrammetry needs a lot of random images around an object, but they have to be somewhat overlap so that it can find common areas and use those in order to create the mesh. Well, this works very similar, except it's done within a application like Maya. There's a Maya script for that, or even in the Unreal or Unity engine. So it uses a technique like that, but keep in mind the camera doesn't move all the way around the scene. It's only in front of it. And that's extremely important because they make a point of saying this will work alongside the first 6 degrees of freedom Daydream headset, the Lenovo Mirage Solo. And I'll play this little video, and I want to show something. Actually, I'll play the ILMX Lab, which was shown last year. funny. Here they show it.
ILM X Lab's
But,
mission is really
If
to
you notice,
create
they don't really spend a
immersive,
lot of time
premium,
moving around the
story-based
scenes, and they
entertainment
really jump
experiences. And our goal is for people to step inside the worlds of our story.
Again, if you want to watch them talk about it, it's fine.
is
But then you
as
see another, and it's always the
thoughtful
same scene.
and creative
They
and
don't
exacting
really
as any of
walk around the scene. Notice it's an open
but
bay.
turns out it's true.
You can have complex scenes with very sophisticated shading that traditionally can't run in real time on an engine.
When I see people in
And there's something very important here. If you notice, one of the scenes
turns out it's true.
You can have
This is down cinematic, but
enabling us
on the VR phone. Turns out it's true.
you can have
but it's significant
very
to
dense,
see
complex
that they're
scenes with very
only showing
sophisticated shading.
That's called the depth map. So what it does is it takes a standard RGB shot from the camera as well as a depth map. Now, they're not really showing what's happening inside the Seurat capture system. They're just showing basically the camera being panned, showing the different layers. But the whole process, which we're going to go through in a second, does something very interesting. And let me show you this. This is the one they just put out. And again, it's very short. And the thing is, let me jump back to this screen. The thing is, in this little example here, and the Seurat system, you point a camera in a particular direction. You take multiple shots, and this can be anywhere from 2 to 64 different camera shots that are supposed to not only capture the RGB information, the red, green, blue, and alpha information of the scene, but also a depth map, which tells you the camera in a color representation how far objects are from the camera. And it takes that information and compiles it in their tool called the pipeline capture. And this pipeline capture then converts it into a mesh. Basically, it looks kind of like rays of a mesh, and we'll go ahead and show that. Man, I'm sorry. I don't realize my throat's been so bad and I didn't bring any water with me. Oh, well, let's see if I can manage. But here they show two examples of the scene generated from, I don't know if this was done in Unity, but at a higher resolution, higher mesh deformation or resolution, and then the Seurat scene. And if you look closely, yes, there are some negatives in using it, but more importantly, you have almost a 1 to 100 reduction in the amount of mesh detail. And with that, you can come up with some pretty interesting scenes. But again, the important thing is, if we go back to this, notice you don't actually move very far. And these 6 degrees of freedom in the Google VR or the Daydream system is set up specifically so that you can't move around very much. So with this, think of it more of a diorama set. And once you start moving too far, and I'll actually show you some examples, you start to see where the illusion starts to break down. For instance, you don't see behind these Japanese lanterns here because on the other side, there is no mesh information. So it's only what you're seeing in front of you, and then basically off to some offset to each side so that if you turn your head slightly left and right, the mesh information still seems to be complete. And again, we're going to show some real detail on how that looks here in a moment. So first, to do this, you have to go out to the GitHub, and there is a Seurat page, and there are a few things here, and you can read the instructions. One, you can go and get the Unity plugin. This is the most complete. So if you're a Unity user, you're going to be happy. The capture system is fairly complete. If you're familiar with Unity, this is a full package, and it seems to load even in the latest beta of Unity. So it seems to work pretty well. Unreal, on the other hand, was just source code. So there was no binary. So I compiled it But sadly, the Unreal does not work correctly. It does not actually capture a death. Now, even though they indicate that it should be in one of the EXR channels, I didn't seem to notice that to be the case. And the outputs from the Unity as well as Unreal are completely different. And then there's the Maya script. So if you have Maya, I have not tested this, but I think that one is fairly complete too. It is essentially a Python script. So you could convert that Python to other tools like Blender and probably use it with that. Why they don't actually have a Blender tool because Maya is not free, I don't know. But I guess mainly because a lot of people use Maya. I don't. But so I may look at it later on if I've got time and convert it. So then it talks about how the scene's created. It creates a JSON manifest, which is kind of like a text file identifying exactly what goes on so that it tells the pipeline encoder system how it was captured and what to do with it. And then the pipeline command line tool has certain parameters that you can work with. And there are a few of them. The most important is the input path and the output path. And again, they don't give you an example of that. I had to figure this out. Some command line tools, you have to put a dash in front of it. And so that was the case. If you go out to my, excuse me, my fork of the Unreal tool, which I'll put in the notes, I have some information not only on how to capture using Unreal, but also how to use the pipeline tools. And thanks to Dimitri, who I think was probably one of the few that actually was able to compile it. So again, these pipeline tools, excuse me again, these pipeline tools, man, I apologize for that. I noticed my throat was scratchy today, so these pipeline tools are also source code and they need to be built, and the build information, let's see, go to this one here, are not very complete. And I think the last time this was updated was 7 days ago, so it hasn't been updated. So there have been a number of issues identified. So they have, excuse me, it can be built as a Linux tool, also Windows, but the Windows build does not work, and they use tools that are kind of strange that you have to download, and it doesn't really give you a lot of information on it. So I failed. A number of people have failed at it, but somebody was able to convert it to work out of Visual Studio and was able to compile it properly. So if your goal is just to get a hold of the binaries, there is a fork of this done by Dimitri, and they're available. And like I said, the Unity capture works out of the box. The Unreal I compiled does not seem to work, but I will put more effort into trying getting that to work as well. So, and I also have complete information on how to use the pipeline tool in my fork of the Unreal tool. So if you're interested in doing this, I think it's going to be fairly complete. But let's kind of go directly into what's needed. I'm going to do a very basic tutorial here. All right, so let me get down and find my little screen so we can get to it. Okay, and it looks like I have a messed up screen again. Let's see if I can fix that. Yeah, there's my problem. Let's see if I can change this. Give me a moment. Okay. There we go. Yay. Okay. Had to change it from 1280 back to 1080p. All right. So excuse my cluttered screen, but I have everything open down here. So let's go into the Unity tool. So let's bring that up. Oops. And let's kind of zoom in here. Okay. Yeah, there we go. Okay. So it's going to be a little slow, and I'll see if I can bring this up. All right, so I've made a scene from an early version of my Van Gogh, and I placed a camera in there. Let's see if I can, there we go. And it's a camera built, and if you look down here, you'll see my list of, my head's in the way. Let me move myself out of the way. So give me a moment. Okay. We will move me over. Oop, there we go. Okay, so if you go over to your crate, and I don't know how well this will show up, but if you use the project they created, you'll have a Seurat capture, and there is, and what I did was just use the standard Seurat capture in the scenes folder. Just double click on that and then add your content to that since that's already set up. But inside there are the tools. And there's actually, you can use their little demo first if you want to. But they have a camera set up in here when you set up the scene, which is right here, called the Seurat headbox capture. And then over on the right-hand side, get to my screen. They have all the inspection details, which are located down here in the capture headbox script. And essentially you choose your output folder where you want these images. Remember, you're going to have a RGB image cube map, which means you're going to have a top, the sides, and the bottom, 6 sides. And for each camera movement, and notice I have sample count of 32. So you can actually reduce this down to only 2 images. And then you can determine the resolution of the center, which means your head box, and then the default resolution. And they suggest that it be 4 times your other resolution items, and that seemed to work pretty well. And then you can determine your dynamic range, and you can select HDR16 or HDR, which provides, I think, 32. So you can provide a much larger dynamic range, and you can import these back into Unity or whatever else you're working with. And then this tells you your last output, and then you just select capture. And if you want to modify, there is a C# script for this, and you can go in there and play with that. But it works out of the box, and then you just hit capture, and then it will basically move the camera around. And I don't know if you can actually see it. I think if you go to the game mode, you can actually see it capturing it. It does seem to turn off all the widgets and just basically captures, and you can see what's in the capture preview here. And it just moves the camera around. I don't know exactly how much, but it's random positions, and each of them are different. And again, it basically captures 6 images per camera location, and those are cube mapped, as well as 1 depth information channel as well, so that it knows the depth of where the camera is to the objects in the room. And I'm pretty sure that's also cube map, and we can take a look at that real quick here. I think I have that open. Yeah, let's look at the Seurat. Okay, yeah, so here we go. So we have a color, and it basically extracts an EXR, which is your HDR, a PNG, which is your standard 16-bit. Actually, I think it's a 30-bit with alpha channel, and then the depth EXR. As you notice, there is fairly large, and it captures this for each of the sides. Here we have the back. If we go down here further, here's the bottom, and here I captured all 32. Yeah, so we have 31 capture. And then you take all of these as well as the manifest, and we'll bring up the manifest. And the manifest, like I said, is like a text file that tells the encoder how this thing was set up. So it tells it it's an image width of 4096 by 4096, clipped from the eye matrix, so it provides the matrix, world view from the eye, and then it tells you the depth type, and there are 3 different types. The standard is IZ, so it's the Z information from the eye point of view, and then the depth information, the color ping, PNG, and then the alpha channel is a constant 1, so there really isn't any alpha information. Then the depth information is, and actually, what am I looking at here? That's true. I'm looking at the depth information. Am I looking at the right one? Yeah. The depth EXR is in channel 0R. Now, what's funny is the depth information out of the Unreal uses the same color EXR, not a depth. And it doesn't actually show it here, but you also have an EXR file as well. Well, it depends. I should take that back. You may not have a PNG if you only selected a non-HDR version. And then here it goes through and tells you the settings for each one of the frames or the camera locations. So you feed this into the encoder. Let's see, I don't know if I don't have it up, but and my instructions showed it. I put those in the root of my E drive and renamed them Seurat Butterfly, which is the viewer, and Seurat Pipeline, which is the standard encoder. And like I said, you put this on I just mapped to E, put this on my command line, a Seurat Pipeline.exe. I actually didn't even put the exe, and then started off with if you go back to the README file, I should have that up here. Yeah, it's for the Unity instructions. Yeah, and we'll go back to this screen. So you basically do your input and then your path. It says default, which if you select the input path to be default of nothing, make sure you put a path in there because it needs to know exactly where the manifest, and you do have to put manifest.json at the end of it. So if you're using Windows, remember your backslashes, but manifest.json has to be in that path file. And then the output, this is very important. Not only do you have to define one, and again, use -output _ path, then your path, but you have to have a directory created for it to find. If you did not create the directory, it will fail. And some of these can take up to 30 to an hour, so you could be losing a lot of time if you don't remember that. And then some of these other features, I just left a lot of these on default. I may go back to them and play with them, but I left all of these on default. You can also set up a cache, which is not necessary, but you could set one up so that way cache information is left there. So if you want to go back and just possibly process a different set of mesh information, they have the example there. So you could process multiple text channels for the same geometry or iterating lighting and shading. So if you want to go back and just change one of these other features here, you could do so without having to reload it. I haven't tried it yet, so I'm assuming that would probably help reduce the amount of time for creating different outputs that can be used later on. And the final output, and let's go back to my other screen. So give me a moment. Okay. Let's go to a Seurat output. You're left with an OBJ file, the EXR file, which is the high definition file, the ICE, which is what is taken. I don't know. I don't think you need any of the other information, but this is a file specifically made for the butterfly viewer so that you can look at these without actually having to bring these into a gaming engine or back into some type of other type of viewer or 3D modeling program. And then you also have the PNG file, which is your standard 24-bit file, RGB at 8 bits plus your alpha channel. And I'm sorry, 30 bits. And you can bring all this into different applications, and there are instructions, and I'll go through that very quickly. First, I went ahead and brought it into Blender. So again, this is the file that was created. And I'm going to go out further. It's seen to create this huge box, if you can see it there. Mouse is not working. Oh, well, yeah. That's what happens when I'm actually using a different machine with it. But you can see here it's capturing, this was done in Unity. So it's capturing the skybox outside the camera. And the reason it did that, let's see if I can get to it, or did I move it around? Great. I shouldn't have done that. There we go. All right, well, you can see it off to the right. So it captures this large envelope of the scene because I put the camera, if you remember, let's jump back. Well, I won't because it takes a little time. But if you remember, the Unity camera was actually at one end of the um, chatting with Vincent room, the Van Gogh room, and because of the bedrooms of Arles. And because of that, that caused a problem with the screen, or what it captured, which is a whole lot of information. So you have to really drill down. There we go. Well, now I can't get back into it. There we go. Well, that wasn't good. I have no access. It's not allowing me to go any further into it. Okay, well, just trust me that inside here, you can actually see it, but as you can see from the outside, it actually captures a lot, but it looks like a big box. So if I go back to Unity, I can actually bring up a scene where I did capture it. So let me bring up that project. And it's very dark, but you can see, if I go out further, I can see the full box. But this is the little box inside, and this is what it captures. Mouse is sensitive. And it's dark because I use the HDR, but I should be able to lighten that up. So let's see if I can do that. So yeah, let's go into the material and just change it out so that you can see it. There you go. So you can see that there are a few, they call them cracks, and they have some solutions to that. But as you can see, it works out pretty well. And again, this is a first try using some default settings. You can see some cracks over here. And then they do have some possible solutions to that. Yeah. But there's the window. And I think you could probably edit some of the extra mesh. Sorry about this. It doesn't seem to work well. Mouse is too sensitive. So here's my camera, and then I can actually launch this using the HTC Vive and walk around it. But notice, this is what I was talking about. Notice the mesh information if I go below the camera, or notice if I am in front of the camera. Jeez. Let's see if I can do this without. Oh, that's not good. But notice, it might be a little difficult to see, but notice the information here around the easel. It kind of looks a little shredded. So everything looked great in the original scene, which we can go back to. But as you move in front or off to the side, or in this case below it, you start to see some of the cracks. And let me go ahead and bring the camera up so you can see what I'm talking about. So if the camera is positioned in the same place that your original Seurat capture was done, that looks almost perfect. But as soon as you start moving the camera too much, you can start seeing behind the scene, to the sides of the scene, which could be huge issues. If that's what you're planning to do, create a more spatial environment. But for using the Daydream 6 Degrees of Freedom, where you actually have limitations on how far you can move, which is basically, I think, only like a foot or 2 feet, this should work more than adequately. And yes, it does greatly reduce the amount of mesh information. The textures are all unlit, so there's no shadowing because it's literally baked in from whatever you're using. So it does seem to work. But again, you might want to ensure if you have dynamic shadows or dynamic objects in there, they should be removed and then placed back in the scene afterwards. So just kind of keep that in mind. And then since all these items are static and they're unlit, if you start using dynamic lighting, which I baked in my own later version of this, all the lighting, I use dynamic lighting to create, first of all, shadows for the animated Vincent, but also to provide some other highlights and things for some of the objects that I created material shaders for, specifically to accentuate using the Unreal Engine. Okay, so this is Unity. Obviously, this is very basic. There are some good instructions out there, and then what needs to be filled in, I provide a little more detail, especially in the Unreal area. So let's kind of take a look. Let me go ahead and close that out. We don't want to say. So let's bring up the Unreal Engine so you can see some of the results in the Unreal. So let me find my Unreal 419. Let's go to the Owl Creek. So if you use my binary file that I compiled for the plugin, I have instructions on how to put it into your Unreal scene. And I'm assuming that if you're already using the Unreal Engine, you're probably already familiar on how to do that. You can either put it into the project file or in the system. I've gone ahead and put it in the system file. Yeah, so this wheel is very touchy. That's not good. Okay. So one of the things you have to do is make sure in your view options, you have your C++ libraries exposed, show your C++ classes, then drill down to your Seurat C++ class, and then find private, which is a Seurat capture camera, and then place that in your scene. And I have already done that, so let's see where it's at. Where are you at? There's your motion controller. Maybe I have to go to. Okay, so let's find my camera. There it is. So I click on it, and this is where you have the actual details and on how to use this capture. And what you have available in the Unreal and is samples per face, just like the Unity. And I have a max of 64 here, and then a resolution of 4096. And then you would just basically hit capture. It does something very similar as in the Unity engine. So you just stay in your editor. In fact, you have to be in the editor. And there are some other features further down that you can work with. Since it's a camera, you could actually use some of these other features, but it highly recommends that you don't have any other features activated. And then here down in the scene capture, your capture source. So you can identify what you're capturing. And then render scene primitives. So you can actually, like, for instance, I have selected a certain number of dynamic, what do you want to call it, objects, like the animals in here that are removed. I took out the water because that's basically a dynamic shader. And when it starts, it basically turns those off, does not render them. And then you go down into these other areas here, show only actors, capture every frame. It's not very clear what this means. If you want to capture every frame, I don't know if that means capture every frame of the like every 1/30th a second, or capturing, I don't know. I left these unselected, and it seemed to work okay. Every time it captures the camera, it captures whatever's, geez. Here, let me do that. And I'm not actually showing what the camera view looks like. But I should be able to go ahead and go to play. There we go. So this is where I have the camera laid out. I should actually have it higher. But this is kind of what it would see. And then it captures the shot. And again, 6 different images for the cube map, which is your top, bottom, and your sides. But the area that is a concern right now, I have to figure out what's going on, is that it does not seem to be capturing the depth information. So when you run it through, even though the manifest seems to work, it's basically just using the R channel of the color to determine depth information. And that's not very good. It's not very complete because it's not really depth information. And it basically creates a little box. And let's see if I can bring up that box so you can see what the output looks like. So my Seurat test. Yeah. And I actually brought in the Van Gogh room from Unity to show you the difference, and I should be able to turn them on and off. Okay, so there's the Van Gogh room. Let's go to perspective. So again, very large. Let's see, I don't want to lose it. If you go further out, see the whole box. So this should all be cleaned up in Blender or some other tool because you don't need, obviously, a lot of this information. But you have a little box, and you have to make sure, in this case, I had to change it from centimeters to meters, but I just multiplied it by 100. Let's see if I can find it here. So it's multiplied by 100 so that it matches basically the size of my first person character. So if I look at this, let's look at a selected viewport. That's the scene. And it looks pretty good until you actually move too far into the scene, and then you can see it. But as you can see there, there's very few little tears that could probably be cleaned up a little bit. There's a couple of them there, and they do look pretty good. This might be a little bit too bright, but it does work. In fact, I don't think that's the HDR. Maybe. So the alpha channel needs to be cleaned up a little bit, but for the most part, there's your scene. So it's kind of an interesting little tool, and it needs some work and obviously more work on my part in order to get some better results, but seems to work. Let's look at some of the other scenes that were captured. It says they're all there. Let's close that one off. Okay. Let's turn them all off. So let's turn them on. So here's some of the scenes that I had captured now, and I showed a little demo of this. Sorry about that. So there's the little box, and it creates the cube box, but there's very little information. And actually, we'll go to a wireframe. See how there really isn't a lot of depth information in the scene. And then when I expand, I think this, yeah, if I go to the scene next to it, let's try and there's more depth information, but that's only because I expanded the number of camera positions, and I think the resolution is the same. So I went from maybe 16 cameras in the original to 32. So I get a little more depth information, but it's not as much depth information as shown in the Van Gogh room. And again, it's because there really isn't any depth channel. Yeah, at least I couldn't determine one. So I've reached out to them. That's the other thing. They don't seem to be very responsive. It's like they put it out there, hoping those who are working with it, like myself, actually take a look at it. But again, it does create this, like, they call it a head box, where you actually have your head, so you can move your head around in the scene, but you really can't do any more than that. Let's see if I can actually, let's see. No, it's not going to do it. Need to turn that off. Oh, there we go. No. Let's move our camera over. It's dark. Yep, there we go. All right, so here's the camera view. There. So once you're in the particular cube, it looks like the real scene. But I notice when you're actually in VR, you can literally see that it's a cube. So that has to be obviously a larger spatial area. So I have to figure out what's going on in the Unreal. It is not complete, and which is kind of sad because that's where I need to work with it there. But the important thing to remember, this is all kind of a mirage, that you're looking at a box that contains projected mesh information of what the cameras are selecting from, depending on how many you use, anywhere from 4 to 32 cameras, random different positions so that you're allowed to move your head slightly and maybe forward a little bit, but it is not the complete mesh information that you would normally have in a scene if you built it from scratch. But obviously, because you can do this, you're only capturing a little bit of the information in front of the scene, and that's what I think is extremely important about this. So there you go. Lots of detail there to absorb. It does seem to work. There are a lot of little tiny issues that need to be cleaned up. Hopefully, the community will make better tools for it and actually make some of them work at all. But if you're using Maya or Unity, you're pretty much golden. As I said, grab Dimitri's binary for the pipeline command line encoder, and you should be able to work with it. Now, it's funny, some of these that I encoded used directly in the viewer, the butterfly viewer, looked spectacular. So they've done some things in there that actually hasn't migrated over to the other tools that obviously have to be worked with. I thought I would have a actual Daydream demo ready, but I was using a different version of Unity. So that didn't work right. So I don't have anything to show there. But using it in the HTC Vive headset, it does seem to work. And I do think that you could save yourself a lot of, basically provide high resolution scenes in a mobile headset. I do think that claim is accurate. However, it's very rough right now. And I think whatever scenes you're seeing right now had a lot of polish done on them before they actually showed them to the public. But I hope to have similar polish on my Breath of a Forest for the Daydream headset, which will be very similar to the HTC Vive, hopefully in the same detail. But obviously, I'm not anywhere close to doing that yet. Okay, well, let me jump back to my main screen. Where do I want to go? Okay, so we'll go back. Okay, so on that note, I'm going to say goodbye. I appreciate you stopping in. If you're looking at this later, just jump to the sections you want. I'm going to work on that so that basically put segment markers in there. I wish YouTube would have tools that were built in to make that a lot easier. They don't seem to translate very well. But on that note, I think that's about it. I would like to thank Engadget, 3D printing industry, 3ders.org. What's the other one that I use all the time? Can't even remember them. Road to VR, lots of good work. I like the reviews from Ben. They're very critical and I think very honest on what's coming up. And I agree with a lot of what he says. And also LinkedIn and Microsoft for their article on their new Kinect sensor coming out, hopefully sooner than later. Okay, so on that note, and don't forget, say a good thought or two for Simone. Hopefully her eye surgery goes well. She will be missed during the time that she's not on YouTube. She gives me a laugh on some of the things, reminds me of my younger days. And I'm glad there are people out there who are still doing these kind of things. And hopefully it adds some fun and attracts other women or young women and men to look at technology, even if it's for, as she calls it, stupid things. But yes, actually, I think she has some more profound words on her YouTube channel for this kind of stuff. But you can go out there and if you're not already a subscriber, go out and support her YouTube channel. Okay, bye. And I'll see you maybe next week or the week after. Don't know. Whenever something comes up and needs some information to be discussed, I will be there. Okay, bye.